Well, we're near the end of the semester, so it's time to review for the final exam. If you look on Canvas, I have posted a final review sheet here with a bunch of review problems that you can work through to remind you of all that you've learned throughout the semester and show you the kinds of problems that could appear on the final exam. I also posted the answers to all of these, and I'm making this series of videos to work you through the answers. If we were still meeting in person, we'd spend the last 2 or 3 days of class going over the final review problems in class. So since we can't do that in person, I'm doing it here on this video. But you'll get the most out of the video if you try working through the problems for yourself before you see how I do them. If you try working through them and you know what you're doing and you get them all right, you're in good shape for the final exam. But anything that you don't know how to do or that you are totally on the wrong track with, that's what you need to go back and look at again and study, and then hopefully when it does show up on the final exam, you will know what to do with it then. So let's start working through the problems on the review sheet. These first few problems, the directions say, solve each system of equations using the method or methods of your choice. Show your work and clearly indicate what your final answer is. If a system is inconsistent, that is no solutions, or dependent, that is infinitely many solutions, be sure to say so. So the first problem is 2x minus y equals 3 and negative 2x plus y equals 5. Now, if you just go ahead and add those two equations together, both of the variables get eliminated because the 2x and the negative 2x add up to 0, the negative y and the positive y add up to 0, and the 3 and the 5 add up to 8. So you end up with 0 equals 8. And since that's a contradiction, that is just plain not true, that means that this system has no solution. It's an inconsistent system. Number 2. Now, there are a bunch of different ways you could solve a system like this. It would work to solve it using the substitution method or using the addition or elimination method. So the way I've chosen to do it is to take the top equation and multiply everything on both sides by 4, because that way I get a plus 4y there to go with the minus 4y in the other equation. There are other approaches you can take. You could multiply the bottom equation by negative 3 to eliminate the x's. You could add 4y to both sides and then substitute in for x, or subtract 3x on both sides of the first equation and substitute in for y. So there's more than one way you can do this. And as long as you do it correctly, you should get the same final answer no matter how you do it. So I've chosen to multiply both sides of the top equation by 4. That turns it into 12x plus 4y equals 20. And I just slid the bottom equation over, and then I added them, and I got the 12x plus the x is 13x. The 4y and the negative 4y kill each other off because they add up to 0. The 20 plus the 6 add up to 26. So now I have 13x equals 26. Divide both sides by 13, you get x equals 2. And remember, we're not done until we know both of the variables. We have a number for x now, so we take that number and plug it in place of x in either one of the equations. I use the top one, so 3 times 2 plus y equals 5. That means 6 plus y equals 5, and then when you subtract 6 on both sides, you get y equals negative 1. So the solution is 2, negative 1. X is 2 and y is negative 1. Number 3. Now, because of the way this one's set up, it's probably easier or more natural to do this one by the substitution method, because one of the equations is already solved for x. It tells you what x is equal to, so you can substitute that in place of x in the other equation. So instead of 2x minus 5y equals 8, when you make the substitution, you get 2 times 4y plus 1 minus 5y equals 8. So now we have an equation just involving y. Remove the parentheses and you get 8y plus 2 minus 5y equals 8. Combine the y terms, 8y minus 5y gives you 3y plus 2 equals 8. Subtract 2 on both sides, you get 3y equals 6. Divide both sides by 3, you get y equals 2. And then plug 2 in for y back in x equals 4y plus 1. And you get x equals 4 times 2 plus 1. That's 8 plus 1, or 9. So the solution is 9, 2. 9 for x and 2 for y. And now we have a word problem, which leads us to a system of equations. T-shirts sell for $6.25 and sweatshirts sell for $11.50. If a total of 73 shirts were sold for $629.50, how many T-shirts and how many sweatshirts were sold? So right away, notice what it is we're trying to find. They're asking us for two things: how many T-shirts and how many sweatshirts. When we know those two numbers, we will have solved the problem. So I'm going to let T and S stand for those two unknown numbers. T for the number of T-shirts and S for how many sweatshirts. Since it was a total of 73 shirts, that means that T-shirts plus sweatshirts should equal 23. And then when you look at the amount of money that represents, $6.25 for each T-shirt, so $6.25 times the number of T-shirts sold, plus $11.50 times the number of sweatshirts sold, should equal $629.50 for the total amount of money. So what we have here is a system of two equations involving the two variables T and S. And there's more than one way you could solve that. I've chosen to solve it by the substitution method. I took this top equation and I subtracted S on both sides so that I got T equals 73 minus S. Then I substituted that 73 minus S in place of T and got 6.25 times 73 minus S plus 1150 S equals 629.50. Multiply out to remove the parentheses, and you get 456.25 minus 625S plus 1150S equals 629.50. Combine the S terms, and you get 456.25 plus 525S equals 629.50. Subtract 456.25 from both sides of this equation, and we get 525S equals 173.25. Divide both sides by 525, and we get S equals 33. And then T is 73 minus S, so 73 minus 33 is 40. So we wanted to know how many T-shirts, that was what the T stood for, and how many sweatshirts, that's what the S stood for. So now we know it's 40 T-shirts and 33 sweatshirts. Now some problems involving factoring. Here the directions say factor out the greatest common factor. There are two terms here. The coefficients, 15 and 25, have a common factor of 5. And the variable parts all have x to at least the third power. So the greatest common factor here is 5x to the third power. Remember, when you're looking for a common factor, look at both the numbers and the variable parts of the terms. So we pull out 5x to the third, and the first term, we need a 5 times a 3 to get the 15, and we need x to the third times x to the third to get x to the sixth. x times x times x times x times x times x, minus, here we need a 5 times another 5 to get 25, and we need x to the third times, well, we don't need any more x's there, so it's 5x to the third times 5 that gives us the 25x to the third. Now we're going to be doing some more factoring, and here the directions say factor completely. So we'll start by looking for the greatest common factor and pulling that out, and then see if there's anything else we can do. So here these three terms have a greatest common factor of 4x. You can pull out the 4x times x squared minus 8x plus 15, and then this x squared minus 8x plus 15 can be broken up further. We need x times x to get x squared. The numbers on the end have to multiply to 15, and they have to add to minus 8. So what works is to have an x minus 3 times x minus 5. So the final answer is 4x times x minus 3 times x minus 5. Number 7, 3x squared plus 14x plus 8. Now here there is no greatest common factor that we can pull out, but we can still break it up into a product of two binomials. We can write two things that when you FOIL them together, you end up with 3x squared plus 14x plus 8. They have to start with a 3x times an x to get 3x squared. They have to end with numbers that multiply to 8, either a 2 and a 4 or an 8 and a 1, and the outside and the inside have to add up to 14x. So here's the way to get all of that to work out. If you take 3x plus 2 times x plus 4 and FOIL it, first you get 3x times x is 3x squared. Outside you get 12x and inside you get 2x, and those do add up to 14x. And last, the 2 times the 4 would be 8. Number 8, here there's a greatest common factor of 10. I can pull 10 out of these two terms so that it's 10 times y squared minus 49. And now y squared minus 49 is a difference of two squares. It's one of those special patterns you have to watch out for when you're factoring. One perfect square minus another, y squared minus 7 squared. So it breaks up into y plus 7 times y minus 7. And number 9 is also a difference of two squares. 49w to the 10th power would be 7w to the 5th power squared. If you took 7w to the 5th times itself, you'd get 49w to the 10th. And the 4 on the end is 2 squared. So this breaks up into two factors that both start with 7w to the 5th. They both end with 2. One of them has a plus and the other one has a minus. Doesn't matter which order you write them in, but we got a 7w to the 5th minus 2 times a 7w to the 5th plus 2. And now solving. X times x minus 6 equals 7. If you multiply this out to get rid of the parentheses, you get x squared minus 6x equals 7. And this is a quadratic equation because it has an x squared in it. So I'm going to get everything on one side equal to 0 on the other side. Subtract 7 on both sides, you get x squared minus 6x minus 7 equals 0. And then this x squared minus 6x minus 7 can be factored into x minus 7 times x plus 1. So for something times something else to equal 0, either the something equals 0 or the something else equals 0. And then we solve each one of those and get x equals 7 or x equals negative 1. Now, once you get to here, this x squared minus 6x minus 7 equals 0, it would also be possible to solve this using the quadratic formula. I think factoring is easier, but the quadratic formula also works. And it's also possible to solve this by completing the square, if you watched my explanation of that. So I'm going to end this video here and come back in part 2 with some more of these review problems.